So let's start the air conditioning analysis of air conditioning system. Okay, generally, so air conditioning. What is air conditioning? Simultaneous control of temperature and air, humidity of air, air velocity, and the purity of the air. Okay, generally, psychometric it is a science which deals with the study and properties of moist air. Okay, properties of moist air. So generally, what is air conditioning? Okay, the cooler which you are using, why you are using that cooler, and what is air conditioning actually? Why can't we use the coolers and all? Why only air conditioning? Okay, so that is the thing. So generally when you look at the air there are two components of the air. First of all, there is a dry air and there is a water vapor. Dry air is a fixed part, okay, you can't change the dryness of the air, right? And there is a water vapor is a variable part. Even though the dry air contains N2O2 and CO2, helium, etc., but the major compositions we are taking N2 and O2 because their contribution is very more in the dry air. All right, so composition is not going to change, okay. So even though if it is a diatomic molecule and the triatomic molecule CO2 is also present, we are treating air as a diatomic molecule, so therefore we are taking the molecular weight of air as 1.4. All right. So water vapor H2, what is the molecular weight of H2? H2 is 18. All right. So air ka molecular weight you are taking as 29, gamma value you are taking as 1.4, right? Right. So our aim is to condition the air. Right. Our main concern is to increase the condition the air. Okay. So generally we are using the air coolers. Air coolers. So our main first priority is to decrease the temperature. In the air cooler we can decrease the temperature, but there are another two more major parameters which you consider. That humidity must be more, and there is purity of the air must be maintained. First of all, temperature, we are going to decrease the temperature, and if we are going to increase the humidity and lack of oxygen, that is purity of air. So if we consider all these three things, we are going to condition the air. Okay, in the air cooler we are only decreasing the temperature, but we are not conditioning the air. Okay? Generally, with the ACs which are using 70% of air, 70% of air is recycled and 30% of are added. Okay, once we add it from the outside. Okay, so generally we can sit only for 7 to 8 hours. In the split LC also, 100% of air is recirculated. So we have to condition the air, right? So a person cannot sit more than 7 hours in that split ACs. Okay, that is the thing. Right. So there are certain psychometric terms which we need to know, okay, before studying the air conditioning. So first of all, specific humidity. Specific humidity, it is a ratio of mass of the water vapor to the mass of the vapor to the mass of the dry air. It is a specific humidity. Kg of vapor to the kg of air. Okay. So generally, if the mass of air is present, mass of vapor is present. Summation of mass is given by m plus m. You know this thing. Then the volume of air is present, volume of vapor is present, temperature of air is present, temperature of vapor is present, and the temperature is a extensive property independent of mass. So temperatures of air and vapor will be same. Pressure of air and vapor, pressure of air, total pressure will be equal to pressure of air plus pressure of vapor. Okay, pressure is a dependent on the mass. Okay, if once you divide, then the pressure. So that is the thing. Volume is independent of mass, right? Right. So dry air once we do certain manipulation, PV equal to MA RT, PV equal to vapor का एक अलग ले लिया अपन और ideal total air का अलग ले लिया, right? If once we divide, we'll get pressure of vapor by pressure of air equal to RV by RA, MV by MA, right? That is omega. So omega value, which is it is gives a specific humidity. So specific humidity is given by mass of vapor to the mass of air. It is a ratio of mass of vapor to the mass of air. Specific humidity, mass of vapor to the mass of air, right? So it is given by 0.622 PV by PT minus PV. Okay, this is the particular equation which you need to know. As a total atmosphere, always consider specific humidity a function of PV only. It is a function of as a pressure of the vapor is going to increase, specific humidity will increase. Relative humidity, it is a ratio of mass of vapor to the mass of vapor to the mass of vapor under saturation condition. So here the main word arises saturation condition. What is saturation condition? Suppose for example, if there is a bottle, if there is a mass of water and we are going to add the sugar, okay, once we add the sugar, then the level of the sugar increase inside the that particular water will increase at a certain limit. It will reach to its maximum value, that is known as saturation state. Similarly, if you take the dry air, and there will be water vapor will be present in the air, right? So water vapor content will be present. If once we add the water vapor, then at one such limit the we can't add more water vapor, right? At that particular limit is known as saturated limit, okay, that is known as saturation air. And we are going to denote the pressure of the saturation vapor pressure is PVS, and saturated mass of saturated vapor is MVS. All right, this is the thing. So PV, V, MVV. If you divide mass of vapor over mass of saturated vapor equal to pressure of vapor over saturated pressure. So generally, if the specific relative humidity is 0.6, what does it indicate? It indicates that 60% of 60% of you know it 0.6. It means that if the mass of vapor is 60%, we can add more 40% to it. If relative humidity is 1, we can't add water vapor to that particular thing. Okay, that is the thing. For saturated air, I know that relative humidity is equal to 1. So this is the thing. All right. Specific humidity tells you about the water vapor present in per kg of the air, right? Specific humidity, mass of vapor or mass of air, कितना vapor present है air में, that tells you the specific humidity. But relative humidity tells you about the moisture absorption capacity, right? How much moisture you can add, right? Suppose the specific humidity value is 0.6. It means that mass of air is 60%, mass of vapor is 40%. Mass of vapor to mass of air. Mass of air is 60%, mass of vapor is 40%, like that. If relative humidity is 0.6, it means that 60% is already vapor is present. You can add 40% to reach the saturation state. Okay. So a question arises that, sir, जब भी dry air है, air we are going to add the water vapor, right? Again, if you add the water vapor, then how till what limit we can add the water vapor? Once it reaches the saturation pressure state, I will talk about that saturation pressure state. Then water vapor can be added. Okay, I will give examples. मटका कूल क्यों होता और कूलर में evaporative जो कूलिंग है थी, why that cooling effect will take place, and ice का क्या है, each and everything I will discuss. Okay, degree of saturation. It is defined as a ratio of specific humidity to the specific humidity under saturation condition. Okay, it is a ratio of specific humidity to the specific humidity under saturation condition, omega by omega s. What is specific humidity at the saturation condition? We know that normal humidity is 0.622 PV by PT minus PV, right? And 0.622 PVS by PT minus PVS. Okay, saturation pressure relative specific humidity. It means that how much water vapor is present per mass. Okay. And that water, after that water vapor, you can't add water vapor, you can't increase the more. What is the specific humidity for that particular thing? Alright, so that is the concept, right? So mu, it is the degree of saturation. So degree of saturation PV by PVS, PT minus PVS by PT minus PV. Alright, so mu equal to phi into PT minus PVS by PT minus PV. So this is the particular thing. What is phi? Phi is the relative humidity, right? So there are some problems once you can solve these problems, okay, very easily. Yes, unit is going to be very simple. Yes, dry bulb temperature, wet bulb temperature, dew point temperature. We'll look at some particular examples and we'll talk about this thing. Okay, enthalpy of moist air, enthalpy of dry air, enthalpy of water vapor. Then we'll go towards the psychrometric chart. Okay. Psychrometric chart, and we'll talk about the psychrometric processes. Okay, and there are certain parameters, okay, which we have to look. So dry bulb temperature, if we talk about the dry bulb temperature, it is the normal temperature which is measured by using the normal thermometer, ordinary thermometer. Okay, generally the temperature which we are measuring, right? Fever, we use a normal thermometer. By using the thermometer, we measure the temperature. That temperature is dry bulb temperature. What is wet bulb temperature? Generally, we cover with the piece of wet cloth and we measure the temperature of water. So that is the wet bulb temperature. So why we are measuring the wet bulb temperature? The question arises. Okay, क्यों wet bulb temperature, क्यों dry bulb temperature? Why we covered with wet bulb? All right. what does it indicates, that we have to see. So generally, we will take one example of matka. Matka is going to get cooled. Why it is going to get cooled? There is one question. Right, matka is going to get cooled. Why it is going to get cooled? Generally, the water will be present in the matka. Okay, so generally matke ke andar there will be holes. Due to that holes there will be cavitation will occur. Okay, cavitation capillary effect, capillary rise will take place. Okay, so what happens generally, the pressure, outside pressure will be less than the P saturated pressure. Okay, so inside pressure will be more. So what happens, the water molecules will try to escape from that particular surface. So in order to escape from that particular surface, what do? They will require some energy to change the phase actually. So they will change the phase and they will escape out. Okay, so question arises that sir, क्यों water का molecules को energy कहाँ से मिल रही, right? Latent heat must be required to change the phase. So from where they are getting the energy to change the phase? They are getting the energy from their own molecules. Okay, so own molecules. So inside molecules के अंदर से energy लेके they will change their phase and they will escape. सो देयरफॉर इनसाइड का क्या होता है, कूलिंग इफेक्ट रहता, कूलिंग इफेक्ट प्रोड्यूस करके जाते हैं, इवेपोरेटिव कूलिंग बोलते हैं इसको। तो कूलिंग इफेक्ट, सो इनसाइड वाटर विल बी गोइंग टू गेट कूल्ड। सर जनरली नेक्स्ट क्वेश्चन इज दैट सर, मटके के अंदर एक दिन में रखे द टेम्परेचर वॉज नियरली अराउंड 22, 23, 18 डिग्री सेंटीग्रेड। सर वंस वी पुट 3 days, मटका आइस क्यों नहीं बन जा रहा, आइस क्यों नहीं बन जा रहा? देर इज़ वन क्वेश्चन. So actually what happens ki you must know ki actually up to what limit the cooling is going to get takes place. Generally the pressure inside the pressure is very more, outside the pressure is less than the saturation pressure. So actually the energy लेता है, escape होता है, energy लेता है ऐसा जब तक कि saturated condition में नहीं आ जाता वो, right? Once it reaches the saturation condition there is no difference in the pressure. Alright, so then once heat transfer is due to temperature difference, heat transfer is due to concentration difference. So this is the heat transfer due to concentration difference, that is the thing. Alright, so जब तक सैचुरेटेड कंडीशन नहीं आ जाता, जब तक एक्सकेप होते रहता तो इतना वाटर कूल होता है. एक्चुअली व्हेन यू लुक द विंटर कंडीशन में और समर कंडीशन में, विंटर में द मटका इज नॉट गोइंग टू कूल. व्हाई? बिकॉज ऑलरेडी मॉइस्चर कंटेंट ज़्यादा रहता है. इट मीन्स दैट टू रीच द सैचुरेशन कंडीशन द ऑलरेडी इट इज़ नियर टू द सैचुरेटेड कंडीशन. सो कूल होता बट उतना कूलिंग इफेक्ट नहीं होता. इसलिए अपन क्या करते हैं, मटका ख़राब हो गया समझते हैं, बट मटका ख़राब नहीं होता. सो इट मीन्स दैट सपोज फॉर एग्जांपल द मैक्सिमम टेम्परेचर टिल द सैचुरेशन से 18 डिग्री सेंटीग्रेड. सो वेट बल्ब टेम्परेचर है ना, वो टेम्परेचर मेजर करता, राइट? सैचुरेशन कंडीशन का टेम्परेचर. ऑलराइट, saturation. We'll look at one graph and we'll talk. Okay, so generally when we pour water on the ground, what happens? Saturation pressure air का ज़्यादा है. So what they will do, they try to escape. So throttling process में भी same होता है. They will take energy from their own molecules. So therefore they will cooling effect आ जाता है अपने को. फर्शी को छीए बोले तो ठंडी दिखती. क्यों ठंडी दिखती? कूलिंग इफेक्ट. क्योंकि वहाँ वो मॉलिक्यूल से एनर्जी लेके वो एस्केप हो जाते, एवापोरेट हो जाते. दैट इज़ द एवापोरेटिव कूलिंग. इन द कूलर्स ऑल्सो यू हैव सीन कि एयर है ना, एयर सर्कुलेट होती है, एयर ये होता है कि वाटर फॉर्म होते रहता, वाटर एस्केप होते रहता. ठीक है, इसलिए अपने को ठंडी हवा आती रहती, एयर से वो करता हो. ठीक है, दैट इज़ द थिंग. वो कॉइल्स की हवा जब लगती, जब ठंडी होती, जब वो ठंडी हवा आती, राइट? दैट इज़ द थिंग. ओके, सो कूलिंग वाटर ऑल्सो, कूलिंग वाटर का भी सेम है, राइट? सो नीचे से जब एयर ऊपर आती, ऊपर से पानी गिरता अपने को, राइट? विल flow some water, so they will get contact and they will cool. Temperature is reduced in that radial cooling. This is one point. What is dew point temperature, sir? Sir, generally we will take one example. There is a glass of cool water. Okay, what happens to cold water? You have seen that water particles will get condensed toward the surface of the cool steel glass. All right. So why it is going to get cool? Why water droplets are going to form from there? Where the water droplets came? Actually generally क्या होता बोले तो, when the air strikes, generally air के अंदर है ना, throughout our environment air is present. So air particles, what will they will get contact, the heat is going to get transferred. Okay, once they reaches their dew point temperature, okay, air is going to get cool, and once it reaches to a dew point temperature, what happens? The dew is going to get formed. Okay, the air particle, the moisture, whatever the moisture is present in that moisture is going to get stuck in the, वो कहाँ से, अंदर से नहीं आता हो, बाहर से एयर का ही moisture रहता हो. क्योंकि एयर में मॉइस्चर जो कंटेंट रहता है पूरा मॉइस्चर पार्टिकल्स है ना उसको स्टिक हो जाता है जब ड्यू पॉइंट टेम्परेचर रिड्यूस होता है। सो विल लुक एट द ग्राफ एंड विल एक्सप्लेन दिस थिंग्स ओके। सो दैट इज नोन एज आइसोबारिक सैचुरेशन, तो कांस्टेंट प्रेशर पे होता जब भी ये अपना मटके का ये होता है ना दैट इज एडियाबैटिक सैचुरेशन। सो जनरली सर पीवी इज अ पीवी एक प्रेशर है लो, पीवी एक वेपर प्रेशर है लो, नॉर्मल एयर का वेपर प्रेशर। So whenever the vapor particles are getting into contact with the glass, the temperature is going to get decrease. Phase transformation नहीं होता. Okay, at one point it reaches to a dew point temperature, and there phase transformation takes place. Okay, then the particles will be formed. So दूसरा condition है सर एक PV air है, right? Evaporative cooling का बोलो, adiabatic saturation. Temperature will decrease. At one point, P-saturated point, temperature is going to get decreased. Point is known as saturated point. Okay, PV temperature is going to get decreased, but dew point temperature achieve नहीं होता, saturation temperature ही अचीव ये होता, right? That is the thing. Then PVS, normal PVS. Okay, that is the case, right? Enthalpy of the moisture. So actually H equal to HA plus omega into HV. This is kilojoule per kg of dry air. Enthalpy of air. Okay, enthalpy of air. Enthalpy of air plus omega, that is specific humidity, into enthalpy of vapor, right? From where this formula came? Generally H equal to HA, enthalpy, total enthalpy equal to enthalpy which is present of the air plus enthalpy of the vapor, right? So generally if we multiply, if we divide with MA, mass of air, if we divide it MA, if we divide with MA, alright, HA को कैसा लिख सकते हैं? already that is capital HA. If you want to write in specific humidity, MA into HA divided by MA, फिर MB into HV divided by MA, MV by MA, mass of vapor to mass of air, it is a specific humidity. From there it came. Enthalpy after trial. Generally क्या है मालूम? We have to take one arbitrary scale, right? At one point reference we have to take, right? At 0 degree centigrade, enthalpy of dry air at 0 degree centigrade arbitrarily taken as 0. Alright. So dH equal to Cp dt. HA equal to 1.0052. Okay, HA equal to 1.0052. Generally there is little derivation you can take. Okay, enthalpy of water vapor, enthalpy of moisture देखें, enthalpy of dry air देखें, enthalpy of water vapor. Where T is in degree centigrade, again सब चीज़ें इसमें degree centigrade में. Enthalpy of water vapor, enthalpy of water vapor equal to HVR. Enthalpy of vapor at reference point plus latent heat plus delta H, right? Enthalpy of vapor. जनरली प्रॉपर्टीज ऑफ प्योर सब्सटेंस अपन पढ़े होंगे, एक मॉइस्चर रहता है, एक ड्राई एयर रहता है, एक वेटर रहता है। वेटर मतलब वाटर वेपर, मतलब सुपर हीटेड वाटर वेपर का कंडीशन। ओके, राइट। सो डेल या लैटेंट हीट प्लस डेल्टा एच प्लस एंथैल्पी एट वी आर, एंथैल्पी एट वी आर इक्वल टू 0, लैटेंट हीट विल बी इक्वल टू 2500 प्लस 1.88 T। ऑलराइट, दिस इक्वेशन यू नीड टू नो। H इक्वल टू फ्रॉम इक्वेशन A, राइट, H इक्वल टू 1.005 T plus W 2500 plus 1.88 T. Okay, this is the thing, right? Next is development of the psychrometric chart. There are some questions after the development of the psychrometric chart. So if you look at the psychrometric chart, generally in the y-axis vapor pressure is present. On the x-axis dew point temperature is present. Dew point, that is the dew point temperature. So generally what we are doing, we are horizontal lines. We are drawing some horizontal lines. Horizontal lines denotes the, again we are taking the scale, okay, omega, right? Horizontally on the y-axis dew point temperature, omega lines will be present. Okay, so omega lines will be present, and left में pressure का is present. Okay, and vertically dew point lines will be present. Okay, when dew point temperature is generally 0, then what is the vapor partial vapor pressure क्या है, कितना है? 0.5 रहता है. Okay, so again as you increase the dew point temperature, saturated dew point temperature अगर से increase कर रहे हैं तो it is going to increase. What is going to increase? Vapor pressure is going to increase. Okay, as you go dew point temperature increase होती जा रहा, तो vapor pressure है ना increase होते जा रहा. Right, so enthalpy one scale we are taking. Okay, enthalpy scale, and the lines which are plotted, that is the enthalpy lines. Okay, H enthalpy lines. Okay, so generally y equal to 1 क्या है? वो saturated condition है. Saturated condition, pressure of the vapor divided by pressure of Vs will be equal to 1. तो saturated condition कर्व लाइन phi equal to 1 की लाइन है वो. उसके नीचे जैसा अपन आते जा रहे हैं नीचे phi के लिए कम होते जाती है. ठीक है. राइट, सॉरी 0.6 रहता, 10 पे 1.22 रहता, फिर उसके बाद 1.2.43, 40 पे 4.24 ऐसा. So we'll join that particular line, we will get the saturated curve. Okay, so horizontal lines denote करते हैं वेपर प्रेशर भी denote करते हैं और अपना ओमेगा denote करते हैं, फिर vertical lines डे पॉइंट टेम्परेचर denote करते हैं. 5-1 की लाइन हाउ यू प्लॉटेड वी नो, ये अपन जनरली है ना 0, 10, 20 सब्स्टिट्यूट करते जाते हैं, वैल्यूज विल गेट 0.6 to 1.22, 1.23 like that. Okay, so constant Weber temperature lines, right? So 10, 20, 30, 40, 50, 60, 70, these are the dew point temperature lines. Okay, so enthalpy lines are present, PV present, omega is present. Okay, right. So right, so actually dew point temperature का ही बोलते हैं अपन, ड्राई बल्ब सॉरी ड्राई बल्ब टेम्परेचर था, ड्यू पॉइंट नहीं था. ड्यू पॉइंट बोलते मैं, वेट बल्ब ड्यू पॉइंट कैसा डिनोट करते हैं अपन, कांस्टेंट वेट बल्ब टेम्परेचर लाइंस कैसा डिनोट करते हैं. So generally कैसा है बोले तो if there is a adiabatic saturation, that is adiabatic यानी constant and enthalpy will be constant. Alright, enthalpy will be constant. Why enthalpy will be constant? Right, enthalpy will be constant. Constant enthalpy. Constant will be time 1000, but for calculation purpose deviation is neglected. So constant will be temperature follow constant enthalpy lines. जनरली भी कंसिडर करें बट एक्चुअली कॉन्स्टेंट एंथैल्पी लाइन नहीं रहती वो, भी कंसिडर करें अपन फॉर द सिंप्लीफिकेशन कैलकुलेशन, इट इज नियरली इक्वल टू कॉन्स्टेंट एंथैल्पी लाइन्स. ओके, सो वेट टेम्परेचर लाइन्स, एडियाबैटिक सैचुरेशन, सपोज फॉर एग्जांपल 0.1 पे कॉन्स्टेंट ड्यू पॉइंट टेम्परेचर लाइन, इफ यू लुक एट दिस ग्राफ पर्टिकुलर ग्राफ, 0.1 पे अपना ये है ड्राई बल्ब टेम्परेचर एयर है. सो एडियाबैटिकली अपन क्या कर रहे हैं, टेम्परेचर रिड्यूस कर रहे हैं, एडियाबैटिक सैचुरेशन, एट वन पॉइंट इट रीचेस टू द सैचुरेशन कर्व, राइट, दैट पॉइंट इज नोन एज वेट बल्ब टेम्परेचर. राइट, कांस्टेंट प्रेशर पे अपन वो करें, कांस्टेंट प्रेशर पे अपन वो करें 0.2 डैश इज ड्राई बल्ब टेम्परेचर, लाइक दैट वी आर गोइंग टू मेजर. सो सेंसिबल हीटिंग, different psychometric processes. Okay, right, so sensible heating, it is a process of increasing dry bulb temperature of air at constant specific humidity. Right, it is process of increasing dry bulb temperature at constant specific humidity. So specific humidity है ना constant रख के अपन क्या करें, टेम्परेचर इंक्रीज कर रहे हैं, राइट, ड्राई बल्ब टेम्परेचर इंक्रीज करें. Humidity constant, humidity lines कहाँ रहते हैं, vertical lines, those are humidity lines. So horizontal we are drawing the line, that is a sensible heating. Okay, T2 is greater than T1, omega 2 is equal to omega 1. So note that sensible heating में अपन humidity constant रख रहे हैं. Again there are things, okay, dehumidification, humidification में heating कैसा होता है वगैरह वगैरह. So generally क्या है, heating coil will be present, mass of अपन mass of air पास कर रहा है, ड्राई एयर वेपर टेम्परेचर W1 वो पास कर रहे हैं. So generally mass of vapor to equal to mass of vapor, there is no condension is going to take place. Okay, so mass of V2 will be equal to mass of V1, mass of A2 will be equal to mass of A1. T2 is greater than T1, actually heating coil से पास कर रहे हैं and there is no condension is take place, therefore mass of vapor, mass of air is going to remain constant, specific heat constant. So Q in calculator M into H2 minus H1, you know this thing. Okay, right, adiabatic process follow constant enthalpy line in the psychometric chart, you know this thing. So bypass factor, generally delta T loss by delta T max. Okay, bypass factor, heating coil है, heating coil का temperature है 50 डिग्री सेंटीग्रेड. Okay, temperature of air है 30 डिग्री सेंटीग्रेड. Generally when you are passing, suppose 40 डिग्री सेंटीग्रेड मिल रहा है अपने को होना था 50 डिग्री सेंटीग्रेड, अपन कॉइल रखे 50 डिग्री सेंटीग्रेड. सो बाईपास फैक्टर क्या बोलता है, डेल्टा टी लॉस, दैट इज कॉइल का टेम्परेचर माइनस T2 डिवाइड बाई डेल्टा टी मैक्स. राइट, कॉइल का टेम्परेचर माइनस T2 डिवाइड बाय डेल्टा टी मैक्स, कॉइल का टेम्परेचर माइनस 30 डिग्री सेंटीग्रेड. राइट, सो बाईपास फैक्टर माने अपन हीटिंग का कॉइल का टेम्परेचर 50 डिग्री सेंटीग्रेड रखे, तो 30 डिग्री सेंटीग्रेड की एयर को अपन को हीट करना है सेंसिबली. राइट, सो स्पेसिफिक ह्यूमिडिटी कांस्टेंट है ना, सो अपन हीट कर रहे कॉइल को 50 डिग्री सेंटीग्रेड, सो 40 डिग्री सेंटीग्रेड अपना T2 मिल रहा. सो बाईपास फैक्टर बोले तो द मैक्सिमम हीट लॉस इज गोइंग टू टेक प्लेस. ओके, मैक्सिमम हीट लॉस डेल्टा टी लॉस, ओके, टेम्परेचर लॉस, दैट इज 50 माइनस 40 टेम्परेचर लॉस हो गया, डिवाइड बाई डेल्टा टी मैक्स, दैट इज TC माइनस T1, अपने को 50 माइनस 30, दैट इज बाईपास फैक्टर. व्हाट इज द एफिशिएंसी ऑफ कॉइल, डेल्टा टी एक्चुअल बाई डेल्टा टी मैक्स. डेल्टा टी एक्चुअल क्या है, 40 माइनस 30. ओके, T2 माइनस T1 डिवाइड बाई TC माइनस T1, डेल्टा टी मैक्स कितना है 50 माइनस 30, 40 minus 30 divided by 50 minus 30. Efficiency is less than 1. Bypass factor क्या रहता सर? 50 minus 40, that is 10 by nearly around 30, 40, 50, 20, right? So bypass factor भी less than 1 रहता और वो efficiency less than 1 रहता, दोनों के मिला के 1 रहता, ठीक है? That is the thing, right? Sensible cooling, process of decreasing the tribal temperature at constant specific humidity. सेंसिबल कूलिंग, ओके, जनरली वही है, कॉइल से अपन पास कर रहे हैं तो वेपर प्रेशर कंडेंसेशन कॉइल का है ना, कंडेंसेशन नहीं कर रहे अपन, कंडेंसेशन नहीं कर रहे, ठीक है? तो वेपर प्रेशर सेम रहता, मास भी सेम रहता, मास ऑफ एयर भी सेम रहता, टेम्परेचर जस्ट रेड्यूस होता, स्पेसिफिक ह्यूमिडिटी कांस्टेंट रहती है, ओके? इसमें भी बाई फैक्टर यू कैन कैलकुलेट, राइट? Humidification, the process of increasing specific humidity at constant tribal temperature is known as humidification, okay? At constant tribal temperature you are going to increase the humidity, that is specific humidity, that is humidification. At constant tribal temperature you are going to get decrease, humidification, dehumidification. Pure dehumidification is not possible practically, right? कांस्टेंट अपने स्पेसिफिक ह्यूमिडिटी कांस्टेंट नहीं रख सकते, स्पेसिफिक ह्यूमिडिटी यानी मास ऑफ वेपर टू मास ऑफ एयर, right? Heating and humidification, this is one of the important things. Heating, humidification, cooling, dehumidification, heating, dehumidification, these are some important things, okay? Advanced two things. So heating, humidification, जब भी अपन हीट करें पहले स्पेसिफिक ह्यूमिडिटी कांस्टेंट करें, अब हीट क्या करें अपन, ह्यूमिडिटी इंक्रीज कर रहे हैं अपन, हीटिंग और ह्यूमिडिटी इंक्रीज कर रहे हैं, so therefore Q in mass of air H2 minus H1, right? Mass of vapor equal to mv2 by minus mv1. तो वेपर का कंटेंट क्या होता, रेड्यूस होता नहीं होता? ह्यूमिडिफिकेशन में यानी अपन क्या कर रहे हैं, ह्यूमिडिफिकेशन यानी ह्यूमिडिटी क्या रहती है अपने मास ऑफ वेपर में, मास ऑफ वेपर ह्यूमिडिफिकेशन ज़्यादा है बोले तो ह्यूमिडिफाई कर रहे बोले तो अपन मॉइस्चर कंटेंट ऐड कर रहे हो इसमें, राइट? सो मॉइस्चर कंटेंट ऐड कर रहे बोले मास ऑफ वेपर बढ़ जाता, सो डेल्टा एम वी क्या होगा, mv2 माइनस mv1, डेल्टा एम वी डिवाइड बाई एम ए, mv2 डिवाइड बाई एम ए माइनस mv1 डिवाइड बाई एम ए, डेल्टा एम वी बाई एम ए इज mv2 ओमेगा 2 माइनस ओमेगा, डेल्टा एम वी इक्वल टू एम ए इंटू ओमेगा 2 माइनस ओमेगा. दिस वाज अ सिंपल डेरिवेशन, यू कैन चेक. यहाँ पे आता सेंसिबल हीट फैक्टर, सेंसिबल हीट फैक्टर, right? Sensible heat factor is sensible heat divided by sensible heat equal to latent heat. Sensible heat factor will be equal to, अब देखो यहाँ पे एंथैल्पी H2, sensible heat factor H2 dash minus H1 divided by H2 minus H1, H2 dash minus H1 divided by H2 minus H1. Alright, this is a sensible heat factor, right? Cooling and dehumidification, T2 is less than 2, omega 2 is greater than omega 1. एयर कूलर एवापोरेटिव कूलिंग जो मिल रही है अपन, इसमें भी अपन क्या है उसको वो टच नहीं कर रहे हैं, राइट? कूलिंग यूनिफिकेशन लाइन को टच नहीं कर रहे, कंडेंसेशन नहीं कर रहे अपन, एयर कूलर एवापोरेटिव कूलिंग एंड ह्यूमिडिफिकेशन, समर कंडीशन, हीटिंग एंड ह्यूमिडिफिकेशन, these are some important thing, but sensible heat factor ले कर लो. sensible heat factor H2 dash minus H1 divided by H2 minus H1, क्या, right? So these are some things. These are the total things about the thing. If there are extras I will add it, okay? ठीक है, अल्लाह हाफिज़. Right, so the main aim of the cooler is to decrease the temperature of, maintain the temperature of the room. Okay, it will not maintain the temperature, but it will decrease. Okay, there is no control over the control of the temperature. And you need to also, the conditioning, the main aim of the conditioning is that we are conditioning the air. It means the moisture content of the air, the humidity, each and everything you are going to control. Okay, you are going to you are going to condition that air, particular air. So that is air conditioning. Okay, so generally there are different terms. Okay, generally in the air what are present? Okay, air, the dry air is present and water vapor, two elements are present. And there are major elements are nitrogen, oxygen, CO2, helium is present in the dry air, and water vapor, H2O, right? So generally we are treating air as a diatomic air, right? Diatomic molecule, mixture of two diatomic molecules is also a diatomic. But if you look at the carbon dioxide, it is a triatomic molecule, but we are considering as a diatomic molecule because carbon dioxide content is very less in the dry air. Okay, so next water vapor का जो ये है atomic molecular weight, that is 18. All right, so that is the thing. So let me discuss about the deeply about why air conditioning. Okay, how the air conditioning is going to work. Okay, so generally in the normal ACs 70% of air will be recirculated. Okay, and 13% of air is added from the outside. Okay, generally in the homes the ACs which you are using, those are not split ACs. Okay, in the split ACs the 100% of air will be recirculated. Okay, you can sit not you cannot sit more than 7 to 8 hours in the split ACs, like in the buses and trains, etc. 100% of air will be recirculated. Okay, there is no any fresh air is going to get added. Okay, yeah, if you want to add the fresh air, then you need to open the windows and you need to you need to add the air. Okay, split ACs and normal ACs. So there are some psychological terms. If you discuss these psychometric terms, then we can, after that there is application, main application where we are doing the humidification and dehumidification, heating, cooling, each and everything. Okay, so first of all, there is a specific humidity term called specific humidity. So what is specific humidity? It is a ratio of mass of vapor to the mass of the dry air. Okay, mass of vapor to the mass of dry air. So what is specific humidity? Why you are denoting why specific humidity? All right, specific humidity, it denotes the how much percentage of vapor is present in the dry air. Water vapor is present in the dry air. Suppose sir, specific humidity is 0.6. Okay, 60%. It means that 40% of water vapor is present in the 60% of air. Right, 100% air is present where there is 40% of water vapor and 60% of dry air. That is the main donation for the denotion for the specific humidity. So there are two formulas. Okay, you need to know the how to find the specific humidity. Mass of vapor, mass of air hai. Okay, you can find it easily. And there is a next formula, that is 0.622 PV by PT minus PV. Okay, this is the formula for the specific humidity. 0.622 PV by PT minus PV, where PV is the vapor pressure and PT is the total pressure. Okay, then relative humidity. What is the use of the relative humidity? It is a ratio of mass of vapor to the mass of vapor under saturation condition. So generally what is a saturated vapor? You need to know saturated air, saturated temperature, saturated pressure, each and everything you need to know. Okay, what is saturated actually? Suppose for example sir, if there is a glass. Okay, in the glass you are going to add sugar. Okay, at one particular limit it will reach to its saturation level, right? You can't add sugar. Okay, you can't add more sugar. Okay, that is a maximum limit where we are going to add the sugar, and that is, it means that it reaches its saturation level. So what is saturated air actually? So if you are going to add the vapor content, okay, you are going to at one particular point, you can't add more. Okay, it means that it reached its saturation limit. Okay, that is the saturated pressure. Saturated corresponding to pressure will be saturated pressure, and corresponding mass will be mass of the vapor, saturated vapor. And normal ideal gas equation, you can use PV equal to MRT. Okay, PVS into V equal to MVS into RT. Similar same two formulas will be present. Psi will be equal to nahi nahi रहने दो. Psi will be equal to mass of vapor by mass of saturated vapor, or pressure of vapor by saturated pressure. So why we are denoting, what is the use of this relative humidity? Actually it denotes that how much percentage of vapor, saturated vapor, is present in the mass of
the vapor. Okay, suppose 90% of relative humidity, it means that 10% you can add saturated vapor, more than 10% is present and 90% is normal vapor. Okay, if it is 1, then both are equal. That is the point. 10% you can add more, right? 10%, if you add 10%, then mass of vapor and mass of saturated vapor will be same. Alright, this is the denotation of specific humidity. And then degree of saturation, it is a ratio of specific humidity to the specific humidity to the specific humidity and the saturation condition. Okay, mu equal to omega by omega s. Okay, right, it is a ratio of specific humidity to the specific humidity at under saturation condition. Alright, right. So mu v will equal to PV by PVS. Okay, PT minus PVS by PT minus PV. Right, PV by PVS you can denote with psi. Okay, there are two formulas. If you know, you need to know the pressures. Okay, pressure of the vapor you need to know, pressure of saturated vapor you need to know, say pressure of total partial pressure you need to know. Okay, when you know these things, each and everything, then you can denote mu. Okay, you can find mu actually. Mu is 0.622 pt by pt minus pv, 0.622 pv by pt minus pv divided by 0.622 pvs by pt minus pv. Right, this is the thing. Okay, you can directly find from this here. Okay, so there are some problems are there. Okay,